Thank you so much to all the attendants, and I hope that now the presentation is proceeding well. Norbert confirmed that you can see the presentation in the right way, please. What I'm going to present you is our solution, analytical solution for natural gas and biomethane quality analysis. And this solution have a background of more than 50 biomethane producer plants, so were applied in more than 50 bioproducer plants in more than 90 transportation national grid points, and in more than 15 biomethane liquefaction plants. So the first slide, as you can see, represent beyond the range of analyzers the evolution that the lasers analyzers manufactured by Endress+Hauser had. So from left to right, you can see the old versions and the new compact version. Just a brief approach to the measuring principle, which is based, as all the optical analyzers, on the Lambert-Beer law. The Lambert-Beer law is, I try to make it simple and understandable. Each component that I want to measure react on a specific wavelength. So if I send a wavelength to a chamber filled with the components I want to measure in quantity, the wavelength will be damped, will decrease its intensity in a proportional way to the quantity of the components inside the measuring cell. The specific benefit of the laser approach, as we have, is that I send only one wavelength through the cell. So in this way, the measurement is free from interferences, is very stable because the laser diode is an electronic device, so its correct behavior is influenced only by the current that I sent to him, and is extremely stable in all its life because the power request for the correct behavior is very low. So let's move to approach the generic biomethane plant scheme. We have everything starts from the digester, where I load the recipe to obtain the biogas. So the recipe can be composed mainly, normally, by waste or agricultural waste. The fermentation of this waste creates the biogas, which is a very dirty and unfair, let's say, media. Because as you can see, we have methane, but also a lot of water and a significant quantity of H2S. In other words, better not to breathe the biogas. From the produced biogas is stored in a tank. From the tank, we separated the two possible destinations, but let's start from the gas phase, which is the most common. From the tank, the biogas is sent to a first pre-treatment, which process I explained in this pre-treatment. Mainly, I have an activated charcoal filter to decrease the quantity of H2S, and then a cooler to dry the gas to a minimum level acceptable by the upgrading or polishing unit. So from the pre-treatment and the upgrading phase, the biomethane is sent first to a quality analysis, where I check with the instrument that we will see immediately after the quality of the gas. If the gas is in spec, then is sent to a compressor unit. If the biomethane is out spec, is recirculated to the biogas tank. If the gas is in spec, is sent to a compression unit, which increase the pressure to the grid pressure. For instance, in Italy, we have different level of grids. We have transportation grids with a pressure that can vary from 12 to 75 bars. So for these grids, the compression unit is always required, or distribution grid, which is a low pressure grid. So the pressure is below 10 bars, and this biomethane is sent directly to the end user. So independently from the grid, the biomethane is sent to the custody meter flow metering skid, where the gas is measured in flow, in quantity, and then the flow measurement is compensated to standard cubic meters. After the custody meter flow measurement, the gas is sent or to the transportation grid, where its quality or the presence of pollutants is checked again, or is sent to an odorization unit, where the mercaptans are added in order to increase the smell feeling of the gas. An alternative use of the produced biomethane is the liquefaction. The liquefaction is adopted when the grid is not so near. So to create the connection between the plant and the transportation grid could be too much expensive. In this case, the gas is purified. We have an additional polishing unit to decrease the concentration of CO2, which is in the standard biomethane in percentage. If I want to liquefy the biomethane, I have to decrease the CO2 concentration below the 50 part per million. Alternatively, the CO2 at low temperature is icing. And then I measure the CO2, and the laser, the TD-LAS analyzer, is the best way to measure a solo concentration in a methane stream, and then I liquefy it, and I have my custody meter flow measurement is done immediately before the load of the produced liquefied biomethane to the tank. Each country has its own rules and norms. Or in other words, we have a general rule which is adopted in all Europe, and the rule is the 16723 part 1 and part 2. And each country, as you can see from this slide, is imposing a number of analyses to monitor the quality of the biomethane. The standard characteristics of the biomethane are indicated in calorific value and VOB index, which is the calorific value divided by the density, the water dew point, which is normally around 50-100 ppms. If you want, you can calculate the concentration in part per millions corresponding to the dew point of -5 degrees C at 70 bars. The oxygen content, the CO2 content, as you can see here, as I said before, in biomethane standard is below the 2.5%. The hydrogen sulfide, the H2S content, which must be lower than 5 milligrams per standard cubic meter, which corresponds to less than 3 parts per million, a very low concentration. The sulfur content derived by the presence of mercaptans, and this is a measurement normally done after the deodorization, and the total sulfur content, which is an analysis which is done in a non-continuous way from time to time. More in details, this is, for instance, the Belgian approach, and you can see, the Belgian approach, and you can see that, as I said before, H2S is again less than 5 milligrams, the mercaptans less than 6, the total sulfur less than 20 milligrams, and the water is below 110 milligrams per meter cube, which correspond to 100 parts per million. So on one side, it is true that each country imposed their own specs, but on the other side, the specs are more or less similar, even because the natural gas, as you know, is exchanged through the countries. France is more or less the same. In Italy, we know much better, of course. We have a specific rule, which is called 11537, which imposed some analysis on a continuous base, and as I said before, is VOB, calorific value, density, moisture, oxygen, CO2, hydrogen sulfide, and hydrocarbon dew point, but only if biomethane is submitted to a GPL injection, LPG injection, and other analyses which are prescribed on a not continuous approach, which can vary from the age of the plant, more frequent after the startup, and if during the life of the plant the biomethane result to be always in spec, the interval between the two discontinuous analyses increase, arriving to 4-6 months. In Italy, as I said before, we approached the natural gas and biomethane plant through SNAM, which is the owner of the distribution grid. There are several inlet points, entry point, from east, from North Africa, from north, from the Netherlands, and some regasification point, which are going to be increased after the beginning of the war between Ukraine and Russia. This is what we do. Our solution is normally engineered and realized, adding to the analyzer itself a sampling conditioning unit, which is engineered to make the biomethane suitable for the correct analysis. This system is realized in France and is then installed on a self-standing rack, which allows the installation of the analytical system directly in field. Zone 1, ambient temperature from -20 to +50. So can be easily installed in the 90% of the European territory. Where there is the possibility that these ambient temperature limits can be exceeded, the solution is to install this analyzer, as we can see later, inside the cabinet with a heater or an AC or a forced ventilation tool. In this other picture, you can see a compo approach. So with the same sample conditioning system, we can measure both H2S and moisture. This is the solution we have engineered for SNAM, and as I said before, we start from the system installed on a frame, and then we include the analyzer with the electrical and power control inside the cabinet. This cabinet can be equipped with an heater or air conditioning or ventilated flow in order to make the analytical system compatible with the extreme ambient temperature conditions. And this is how it appears when it is installed in field. Specifically, this is a transportation grid entry point. We have already realized more than 90 of these installations. So why, for instance, SNAM, the national grid owner, choose Endress+Hauser for its quality applications? As first, because of the reliability and analytical performances. These are two calibration certificates where you can see that the analytical performances are much better, are exceeding the performances allowed. So here we have plus minus, for instance, on moisture, we have ±1 part per million, whereas the result of the test indicate a performance 10 times better, and the same for the H2S. So reliability and accuracy. This is the view of the display. The picture is not the best, but as you can see on the bottom, the measurements are really good. How can we obtain this result? We can obtain the result through an analytical approach which is subject of copyright by a licensed approach, licensed by Endress+Hauser. This approach is called differential measurement approach. The concept is very simple. Laser, as we said at the beginning of this presentation, is really performing very well in presence of change of the background and interferences, but is not completely free from this problem. So when the analyzer feels that the change of the background is significant and could affect the measurement, or that interferences are coming, the firmware of the analyzer switch solenoid and let the gas pass through a scrubber. The scrubber is, let's say, a filter selective on H2S or moisture, according to the application. Let's say H2S, which is the most common. So the gas passes through the scrubber and goes to the measuring cell. The firmware of the analyzer stored in memory the wavelength, the profile. Immediately after, the solenoid are switched again, and the gas is sent as it is, so without any filtering action, through the measuring cell, and the new spectra is stored. It's easy to understand that the difference between the two spectra represent the concentration of H2S free from interferences and allow the analyzer to, adopt this new frequency as the right frequency where to perform the analysis. This is the picture of the scrubber. The scrubber life is at normal concentration as we intend in natural gas or biomethane, even more, let's say below 50 parts per million, which is a high concentration, can last around 5-10 years. So it's not a 2 years per part. It's something that lasts longer. And the efficiency of the scrubber itself is monitored by two systems. A software, which is taking in account the number of scrubbing cycles and the concentration, so can calculate the saturation time of the scrubber, and a visual indicator which change color when the scrubber approach its end of life moment. These are all the different phases we pass through before achieving our last configuration. So, as I said before, we started from the Endress+Hauser analytical approach only, but then the market requires a complete integration. What I mean with complete integration, the integration of non-Endress+Hauser third-party analyzers, like the gas chromatograph for the composition analysis and the calorific value calculation, and the oxygen analysis. With this configuration, we satisfy all the needs, all the requirements for the biomethane quality analysis. And this is the last engineered solution. As you can see, we have the new moisture model, the already existing H2S analyzer version, which will be soon converted to a version similar to the J22 moisture, a common sample conditioning system, a gas chromatograph for the calorific value, CO2 and composition analysis, and the oxygen, all inside a new engineered self-standing rack, which can be easily closed with front doors. Talking about LNG, what we do is mainly adding the CO2 analyzers to monitor the concentration of CO2. As you can see in this picture, all the analyzers are installed on the same frame, and we can also add a quantity measurement, so that the custody meter flow measurement on the truck loading. All the system is certified MI 005. And now I leave the speech to Norbert, who can explain how we approach the European engineered solutions. Norbert, the stage is yours.
Thank you very much, Marco, and I hope that Norbert can step in. Yes, we can see you, and I hope we can hear you as well. So.
Yes, gladly. Before I start, any question from our guests or comments? If not, I'll proceed. So thank you, Marco. Maybe a brief summary what we saw, and based on our experience in the last 10 years, what we saw at biogas plants. Generally said, for the biomethane quality before injection, the responsibility is at the biomethane producer. And what we see generally is a gas chromatograph. The motivation using gas chromatograph is composition and complying to OEM 140. So practically custody transfer gas quality. So the main motivation is the commercial one, but we must focus on the safety as well, and exactly measuring these components like moisture or dew point or H2S serve this motivation. We can ensure that in a very low so-called trace concentration, limit values can be kept, and this is important as well. What we saw, there is a huge discussion country to country, which is the right scope on side of the biomethane producer or on the DSO side. Where is the interface? How these participants collaborate with each other? And I think this is also our responsibility as a measuring device supplier, not only selling the devices, but also ensuring that they will be working fine. And therefore, we provide the opportunity for exchange. We establish and accelerate networking processes within countries, and also we support international networks. As you can see on this slide, Endress+Hauser organized many times between DSOs from different countries exchange, because the status is still we have no standardized solution. The requirements are different country to country. And I think a common goal should be achieving standardized requirement. And the first step is, of course, communicating, exchanging, sharing experiences. And we see our role as Endress+Hauser, because outside of providing devices, also ensuring the proper functionality during the whole lifetime. And Italy has in the biomethane market a very significant role, huge experience, and my Italian colleagues are very well networked, and they're gladly sharing these contacts and experiences. In Austria, we also started some activities. If you ask what about the maintenance requirement, End of last year, we had for dew point measurement based on moisture with our J22 demo reference measurement in a high pressure application. And we said we will not deliver a brand new device. Let's take a 3-year-old analyzer, demo analyzer. So it was produced, calibrated only once, and this device has been traveling all over the world and installed, shipped to the next customer. So quite untypical operational circumstances. And we told the customer, you will see, and this is the right answer to the maintenance requirements. Because we have no moving part, there is no sensor medium contact. And this is an optical device. And we closed this test project in Austria with the best results, and we got official references. This is not about pushing one technology. This is much more staying in exchange and learning from each other. We have, of course, our idea and opinion, but we are also open for your comments, questions. While Marco is showing some experiences, I think this is the project. We compared our device with the so-called chilled mirror technology. We were expecting much faster measurement and much more accurate measurement. This figure was created not by us. As you can see, Endress+Hauser is typically blue, but this time we are the green one, and the red points are from the manual measurement with high accurate manual sampling. And as you can see, our 4-week testing in the laboratory, there was the possibility switching from more streams. And the first bigger change you can see we could follow, and it was point landing. Also the second one, and right at the beginning the customer asked us, can you set an offset? And we said, yes, generally it's possible, but please wait a bit. And roughly after 1 good week, the customer said, we will set an offset, but for our device and not for Endress+Hauser device. And since then, the measurement were quite similar. However, the very fast reaction time you can see in the figures, and also the changes. So much more reaction, generally said, and it could be useful because in the future we are expecting more and more injection points. The natural gas grid. It's not like in the past you had 1-2 sources and very few biogas plants with injection. The tendencies, the number of these injections will be growing, and of course you need a very fast analysis. And the optical analysis is, based on our opinion, the right solution for that. Please, next slide, Marco. And one additional information, we are member of the European Biogas Partnership, Industrial Partnership, and in the most countries we are working very closely together with associations like Gas Association, Biogas Association, and we need to try to understand the motivation, the local specialties. As a global player, I think this is very important for us. So we kept our presentation a bit shorter than 60 minutes, and we would like to provide room for comments, wishes. Of course, this time is very short of each topics, each technologies, applications. We could talk many hours. We wrote many articles in professional magazines. Today, we just wanted to provide a general overview. And if I can summarize in a few points, the major message to you is measuring gas composition based on commercial motivation is not enough, because biogas can contain very dangerous components. What we saw, the biogas upgrading system suppliers say our system works fine. This is always the general statement, and I believe there are great biogas upgrading system provider. But what about aging? What about if someone changes the feedstock? And yeah, trust is good, but control measurement makes sense. Of course, there are a lot of components you can monitor. We need to minimize the investments combined with these injection points. Therefore, we use oxygen measurement by a third party. However, we have also our optical analysis for oxygen. And generally, we say there are two components are very important to measure online. And between online and online, there is also a huge difference. Somehow, online means 4 measurements per hour. In another country, 1 measurement in 1 minute. So this is also important to understand, but the more frequent, then better. And safety shouldn't be a compromise.
Thank you. Thank you very much, Norbert. Thank you very much, Marco, for really, as you said, overview based on already long experience with providing solutions for measurement and for gas quality under control. I would invite our participants to put the question, and they see one from Goran Nikolovsky. So, Goran, if you like, you can unmute yourself and put the question, or I can read it. So whatever is better. So no unmuted Goran from Ministry from North Macedonia. So this is actually the question about the update on status of on directive on common rules for in renewable and natural gas and hydrogen. So this is actually question for me or from somebody from European Commission. So what is with directive, which we call fourth gas package or fourth energy package? Directive and regulation are recently approved by the parliament, adopted by the parliament, and now the same procedural step should be done by council. But this is actually the text agreed by the end of the year between two bodies. It was just formal step to let's say to adopt it. When they will come to energy community contracting parties, we will see. I mean, for this year, not for sure, but they will come. I mean, it cannot be avoided, and it's not idea to be avoided, because anyhow, this aim is to have integrated markets. So while waiting for other participants to put the questions either in chat or to raise the hand. I actually have a few, and you partially, Norbert, you answered to it. So frequency can be, let's say, 4 times in hour or 1 per minute. So I believe this is then the same equipment, just requiring adjustment and setup actually different. Am I right or wrong?
This is a very good point, and also there are many other points to be considered. Where to inject? Is it a DSO grid or DSO grid? What about the production capacity? Are we talking about a small scale biomethane plant or a bigger one? And therefore it may influence the whole instrumentation needed. So there is no general remedy. I think we can be happy if we finalize the major technical parameters to be monitored, how to be monitored. And of course, we don't need to go to high end if we are talking about 200 cubic meter biomethane plant today. It's not to compare with 10 times bigger capacity biomethane plant.
So this is partially already the answer also for pressure. So of course it's different if it's on distribution network or on transmission network, and then we have completely different pressure. So Marco has the answer. So please.
We have to consider that when we inject biomethane in a transportation grid, we are sending our biomethane independently from the flow. We can move from 250, as Norbert said, to more than 2,000 square cubic meter per hour. The condition is that in the transportation grid we have millions of square cubic meter per hour flowing. So under this point of view, the quality of our biomethane is monitored mainly for custody meter matters. Okay? More stringent, I would say, more important is the biomethane quality when we inject it in distribution network, in low pressure grid. Because the gas that we are injecting in distribution network is directly sent to our houses, to our kitchens. Okay, so if there should be too much H2S, the problem is real and immediate, because we will see the flame on our kitchen yellow. And the result of the burn of the flame is potentially pollutant. So the necessity to correctly measure the biomethane quality is always present. Always. And is even more important when we inject the biomethane in the distribution grid, in the small networks. Because in the small networks, the biomethane is immediately, how can I say, used. And the non-conformity could really become dangerous.
Thank you. Thank you for that. So we have a question from Natalia. So Natalia, if you like, you can unmute yourself and put the question.
Yes, hello. Thanks for the opportunity. My question is to speakers. Can you please tell your experience of your country? Maybe are there any specific technical safety requirements for distribution, transmission, consumption of biomethane compared to natural gas, or it is biomethane is treated like natural gas in pipes? Thanks.
I can answer for Italy, and I confirm that biomethane is treated as the natural gas. The specs are extremely similar. Pollutant concentrations are the same. Even our products, which are applied for the quality measurement, are the same as for biomethane as for the natural gas. Specs are almost the same.
Yes, the same in Austria as well. I visited 2 weeks ago the Austrian Gas Association, and yeah, I asked, is it really necessary monitoring all of the limit values? Because if you can prove the origin of the biomethane, components like total sulfur or mercaptan and so on, maybe are not so relevant, and there is always a question how to reduce the scope of investment, and very important question is always the relevance. And of course, in addition, which components to be monitored continuously, and at which points are sampling enough. I am in a quite good contact to my Hungarian colleagues. We visited last week the Hungarian DSO, and in the surrounding region, I can say generally the major requirement is the same like in natural gas, because there is still no new rule. In Austria next week we will organize our gas profession day, and we will ask again the Austrian Gas Association, Biogas Association, because I think these are topics, and the requirements are more or less the same still, because there is nothing new. But it doesn't mean after years it has to stay the same.
Thank you. This is actually answer to my question, which I prepared, and that would be comparison if same equipment can be used, of course, for natural gas and biomethane, or do you see some differences? But you answer it already. I mean, from setup of equipment point of view.
Yes. Maybe Marco, if you go back to your slide, to this general plant overview, where you have the standard biomethane characteristics, it proves the statement we can use the same equipments for biomethane.
But what would you say now when it's injection of biomethane? Which component should be really monitored all the time and very closely? Which was not, for example, case for natural gas before. I mean,
water dew point, H2S for sure. Maybe oxygen.
Yeah, with oxygen, it was a lot of questions and raised issues about content of oxygen, because from one side, if it's too low, then it's problem for biomethane producers. I mean, they would need to invest more. This is what I heard. Or then, if we enter into really safety issues from actually grid operator side, but you don't see the big problems there. I think that it's still a huge range between this adjustment for producers and really limit from safety risks.
May I answer?
Yes,
Yes,
of course. Please.
Yes, okay. Because okay, so we could divide the need for monitoring the quality of the biomethane on two different levels. The first is safety. Safety means that we have to keep under control mainly H2S because it's and total sulfur because it's a corrosive component. And the corrosive action of H2S increase in parallel with the increase of moisture because H2S and moisture create sulfuric acid. So the two components which are kept under control are mainly H2S and moisture. And I would say CO2. Then the other reason why we keep under control, we monitor the quality is mainly the calorific value. In the sorry, in the Italian rule, the ones I mentioned before, the 11537, the composition of the biomethane is not really defined. When I say composition, I mean the concentration of the hydrocarbons inside the biomethane. We start from the assumption that biomethane is mainly methane. So we will have more than 90% of methane. So we expect to have, for instance, a calorific value lower than the one of natural gas. The configuration of the GC to measure the calorific value can be different from the configuration of the GC for the calorific value measurement in
Unfortunately, we lost Marco. So from bad connection, but yeah, the question almost answered fully, and it cannot cover all experience Marco has, as we can see, and then Norbert as well. So maybe we can start in the meantime until Marco is back. Maybe Norbert, from your experience or your company experience, technical constraints for blending hydrogen, because we have the question here, and it's always like, yeah, it can be up to 10%. No, it can be up to 20% without problems. So from your experience,
it's depending also on the system. There are already 100% repurposed pipelines as well, without changing anything. Generally said, 2% is allowed, injecting into the grid. And I'd say maybe for hydrogen, I'd propose a separate question. And we could check the whole power to gas process. Maybe from the analyzer point of view, we had the project in the US for injecting hydrogen right for gas turbine at the power plant, and we increased the portion of injected hydrogen. And of course, it needs certain validation because it can cause huge damages in the turbine, and there is also a safety aspect. And the so-called Raman analyzer, we applied for this analysis. I've wrote end of last year article in the Austrian FGW magazine. I can forward. So this is always country to country different. We are in touch with the Austrian institute. This is a spin-off of the Technical University Graz, and there are some projects and there are already nice results regarding repurposing existing natural gas grids, different material, different age, different systems. And as mentioned, we are not only analyzer manufacturer, we have any other parameters, and other devices have also completely different requirements. A very simple example is the pressure transmitter. To ensure the tightness of the measuring cells, we apply gold coating, 25 micrometer, and it ensures this gold coating that the system is tight.
Thank you. Thank you. I see that we have already introduction for the next topic, next possible topic, which can be hydrogen. And then just to thank you, Marco, for being back. And despite all technical difficulties today, you really did it.
Hear me.
Job, and then you gave us a nice overview. So if you want to actually maybe to finish answer to previous question or to put final message, I mean, all is fine.
No, it's the final message to my previous intervention is it doesn't matter where is the end destination of the biomethane. What is important is to measure its quality in the best possible way. Reliability and accuracy again.
Thank you. Thank you. Thank you for that and for overview. Thank you to you both. I mean, really for presentation, for sharing this knowledge and experience with us. We will put our presentations slides at the website. We recorded this webinar. This is also possible to check again what was given today. And as I said at the beginning, we started slowly with this webinar, detecting actually really interesting topics and matching them with experience which already exists from experts and from the companies. And all this has to be tackled in this energy transition towards decarbonized gases. So next session is planned for July. Then we will think about during summer what to do next. Shall we put this on monthly basis? Which topic to be included? And for today, that was it. So many thanks to our speakers again. Really excellent presentations and technical overview and experience, all in 30 slides and 60 minutes. So thank you for that, and I wish you a nice day and see you in 2 months' time. Let's put it that way.
Thank you so much. Bye.
Thank you very much.
You all.
Bye.
Bye.
Thank you.
Bye.
Bye.